Okay, so we're finishing off with a review of yesterday, and all we're going to be doing is definite integrals. And we're doing definite integrals. If you remember the definition yesterday, that means that we'll be finding a solution, and the c's will cancel. Okay? So, the first thing, let's just get this so we have all exponents and not that square root sign. So 1 minus 4x cubed to the 1/2 dx. Okay, and we're going to do just like we did yesterday. We are going to pick the inside as our u is 1 minus 4x cubed. Okay, we'll take the derivative of that, which is du over dx, will equal negative 12x squared. Okay, so from negative 2 to 0, we'll have 2x squared, u to the 1/2. Oh yeah, these two trade, right? So this will be times du over negative 12x squared. Okay, the x squareds will cancel, and the negative 2, or sorry, the 2 over negative 12 will be negative 1/6 u to the 1/2 du. Okay, so if we take the integral of that, this will be 1/6 times, so 1/2, if we add 1, that'll be 3 over 2, right? So we're going to have u to 3 over 2, so I'm going to put a 2/3 here. And then we write it like this, because we've done the integral, so we're going to go like that. And this equals negative 2 over 18, which is negative 1/9. We can substitute the u in, which is 1 minus 4x cubed, all to the 3 over 2. And we don't have to put the plus c, and then that is negative 2 to 0. Okay, so all the way up to right now is 100% review, right? The only thing that's new, which isn't even new because we've done this when we find area, is we're just going to subtract the upper minus the lower. So to do that, that'll be negative 1/9, 1 minus 4x cubed, oops, not x anymore. We would have 4 times 0 cubed to the 3 over 2 minus negative 1/9 minus 4 times negative 2 cubed to the 3 over 2. And then this gives us negative 1/9 minus negative 1/9 times the square root of 33 squared. Okay, so we could just take out a 1/9 or negative 1/9. Let's take out, leaving me with 1 plus root 33 squared. Cubed, sorry, that's cubed. It's 3 over 2. Yep. Okay, so we're just going to ignore this because we did it. Okay, so that's it. That's the only thing today. Now, there is another thing I'm going to show you. If you just know how to do it, we did there, then you're good. But there's another way to do this, and it's by changing the limits at the u equals stage. So where you see where we had u equals 1 minus 4x cubed. You can actually put in your upper and lower. So at x equals 0, that would be 1 minus 4x cubed. That gives you the 1. And then at x equals negative 2, 1 minus, I guess I should put a 0 in there. 1 minus 4 times negative 2 cubed gives you 33. Now remember, this was the upper limit, and this was the lower, right? Because it should go with the upper and lower of the two numbers. And then you could see when we were at this stage here, you know, kind of here, we didn't actually multiply these together. I'm going to put this. But if you take this and you bring it down here, this would be negative 1/9 u to the 3 over 2. And all you do is you change your upper and lower limits to be 33 and 1. Okay? So I took care of the u by putting into 1 minus 4x cubed. I put my upper and lower in there and then got new upper and lower. And then you just have to do negative 1/9 times 1 to the 3 over 2 minus negative 1/9 times 33 to the 3 over 2. And you'll get the same thing, negative 1/9 times 1 minus 33 cubed. So is one better than the other, more preferable? Whatever you like. It's just to know the two ways exist, so when you're again seeing this next year, you can keep the u in there and make new upper and lower limits by putting it into what u equals. Okay, so we're just going to do one more example of doing it two ways, and that's a wrap. Okay, so we got 0 to pi over 2 of x cos x squared. So we'll make, okay, so for this one, let's kind of split the page in two and we'll do it our two ways. But we have u equals x squared, du over dx equals 2x. Therefore, du over 2x equals dx. Okay, so if we're doing it the first way, 0 to pi over 2 of x cos u du over 2x. The x's cancel, so I'm doing the integral 0 to pi to 1/2 cos u du. Okay, now if I do the integral cos u, I would get sine u. And then that is to 0 and pi over 2. Okay, so on the left side I'm going to substitute my u back in, which is sine x squared pi over 2 and 0. So 1/2 sine pi over 2 squared minus 1/2 sine 0 squared. Okay, this would be 1/2 sine pi squared over 4 minus sine 0 is 0, so 1/2 times 0, it's just going to be minus 0. Gives me the answer 1/2 sine pi squared over 4. Okay, now if I was to just go right from here, well, I need to find out what u equals. So at x equals 0, u equals 0 squared, which equals 0. At x equals pi over 2, that would be u equals pi over 2 squared, which is pi squared over 4. Okay, so now my new integral would be 1/2 sine u from 0 to pi squared over 4. So it'd be 1/2 sine pi squared over 4 minus 1/2 sine 0, which would give you 1/2 sine pi squared over 4, because that cancels. Okay, so again, just to get you familiar with seeing it, so next year it becomes something that you can remember seeing.